Good morning, everyone. Hopefully your second day of e-learning is going well. I'm going to do the mixed gas laws practice problems number 2. So remember, if I go too fast for you or something like that, then you can always, pause the video, write down what you need to write down, and then you can just, get back to working. Alright, so yesterday I posted a video online, and for some reason Google Drive didn't work, so then I just posted it on YouTube. So I'm going to post this one on YouTube after I'm done with it as well. Alright, so a gas has a volume of 250 milliliters at 273 Kelvin. At what temperature in Kelvin would the gas have a volume of 50 milliliters? Alright, so just to review with you for a second, ml or L, that's going to be a volume. Alright, if we have mmHg, torr, atm, which stands for atmosphere, mmHg is milliliters of mercury, atm, we have psi, which stands for pounds per square inch, and then we've got kPa, which stands for kilopascals. So all of those are pressures. Alright, and in case you didn't know this, degrees Celsius and Kelvin, those are both temperatures. Alright, the only time that you'll use amount of gas is if it is moles. Alright, so we've got 250 milliliters. Alright, so I just told you up here, if it's milliliters or liters, it's going to be a volume. So we're going to put volume here. 273 Kelvin, is that a pressure, volume, temperature, amount of gas? It's going to be a temperature. Is 50 milliliters a pressure, volume, temperature, amount of gas? That is going to be a volume again. Alright, so now you can get out this flow chart, and I posted this yesterday on Classroom in case you were, you're missing it or something like that. Alright, so you just told me that it was volume and temperature. Alright, so volume and temperature is this second one here. It's going to be Charles's law, and we're going to use this V1 over T1 equals V2 over T2. So I'm going to write in Charles's law, and the formula is V1 over T1 equals V2 over T2, just like that. Alright, so now in these blanks I'm going to fill in V1, T1, V2, and then T2. Alright, so the first thing, it says 250 milliliters. Is that a volume temperature? That's going to be a volume. Alright, so I'm going to fill it into this. Alright, and remember, how do you know that certain things go together? Remember, if they're in the same sentence, they definitely go together. Alright, so I'm going to zoom this in, just, make things a little bit easier. Alright, the next one is 273 Kelvin. Alright, and some people may ask, why don't we have to add 273 to this? It's already in Kelvin, so we don't need to. Alright, and the second volume is going to be 50 milliliters, because it says that right up here, 50 milliliters. Alright, so then this T2 has to be our X. So I'm going to plug these into the formula. So it's V1, which is 250, divided by 273 equals 50 over X. Alright, now to solve this, I'm just going to do cross multiplication, like so. Alright, so it's going to be 250 times X equals 273 times 50. Alright, so now I'm going to get out my handy dandy calculator, and I'm going to do 250 times X is just going to be 250X. So I'm going to do 273 times 50, and that's going to get me 13,650. Alright, so this side is just going to be 250X. Alright, and this side over here is going to be 13,650. Like so. Alright, so now to get this X by itself, I'm just going to divide by 250. Because this is multiplication, I'll just do the opposite. And whatever I do on one side, I have to do on the other side. So now I'm just going to do 13,650 divided by 250, and it gives me 54.6. Okay? Alrighty, so there you go for that one. So 13,650 divided by 250, it's 54.6. Alright, and then you have to ask yourself, okay, what unit should this be in? It should be in Kelvin, just like that. Alright, so remember, if you get behind or something, just pause the video, and then you can write down the things and then catch up with me. Alright, so let's go on to the next one. Alright, so it says, a sample of oxygen occupies 47.2 liters under a pressure of 1240 millimeters of mercury, or mmHg. What volume would it occupy if the pressure was decreased to 730 mmHg? Alright, so if you look back at the first sheet that I just did, up here at the very top, milliliters or liters has got to be a volume. Alright, so 47.2 liters, that's going to be a volume. 1240 millimeters of mercury, or mmHg, that is definitely going to be a pressure. So remember, we have 5 different units for pressure, and they're all up here at the top. mmHg, torr, atm, psi, kPa, all of those are going to be pressures. And then finally is 730 millimeters of mercury. That's definitely going to be another pressure. Alright, let's get out our handy dandy gas laws flowchart here. And we were given volume and pressure. So, if we look here, it's going to be pressure and volume. That's going to be Boyle's law. And it's going to be P1 V1 equals P2 V2. Alright, so which gas law should I use? Boyle's law. And what is the formula? P1 V1 equals P2 V2. Alrighty, so now let's plug in these. Alright, so P1 V1. And you may be asking, well, why did you go across like this? That's just the way that my brain sees it. You could have gone down with the V instead of that. So P2 is going to go here, and then V2 is going to go here. Alright, so the first pressure that I encountered, you told me here that this is pressure, so it's going to be 1240 mmHg. Alright, the V1 is the first volume that I encounter, and that one up here is going to be 47.2 liters. So a lot of you have asked me before, how do you know those two go together? They're in the first sentence here together, so I just group them together as your P1 and your V1. Alright, the next thing that we encounter, 730 millimeters of mercury, that was a pressure, so it's going to be 730 mmHg. And then V2 is going to be our X, our unknown. Alright, so we're going to plug these into this formula up here. So P1 is going to be this 1240, so 1240 times 47.2 equals 730 times X. So I just did this parentheses thing here and the dot over here. These two things mean exactly the same. Like this is multiplication and this is also multiplication. So it doesn't matter how you write it. Alright, on this side we're going to do 1240 times 47.2. And that's going to give me 58528. Alright, and then on this other side it's going to give me 730x. Because you can't combine those. Alright, so now, to solve this, since this is multiplication here, 730 times x, to get this x by itself, we're going to do the opposite of multiplication, which is division. So I'm going to divide by 730. Whatever I do to one side, I have to do to the other side. Alright, so now on my calculator, I'm going to do 58,528 divided by 730. And that's going to give me 80.175, so I'm going to round it to 80.18. Alright, so now we have to ask ourselves, okay, well, what unit is this in? So remember, the volume units have to match. So if this is liters, this is also going to have to be liters. So it's going to be 80.18 liters, and you can fill that into the chart up here. Okay? So let's move on to the next one. And again, if I'm going too fast for you, just pause the video, catch up, write some things in that you need to, and then hit play again. I'll still be here. Alright, next one. It says, on a cold winter morning, when the temperature is 260 Kelvin, the air pressure in a car tire is 1.5 atmospheres. What is the pressure after the tire is warmed up to 288 Kelvin? So if you didn't know this, your car tires, the air that's inside them actually heats up whenever you drive your car. because of the friction. You know, the wheel contacts the road, and then it creates friction, which causes heat, and then the heat heats up the gas. But whenever it's cold, the air pressure in your tire actually goes down, which is interesting to think about. So I'm sure you might have gotten in the car before in the morning and it says low tire pressure, and then as you start driving your car, you know, as the gas heats up, it expands and the little thing goes off, the little light goes off. Alright, so it's 260 Kelvin, a pressure, volume, temperature, amount of gas. It's Kelvin, so that's going to be a temperature. Alright, 1.50 atmospheres. Is that a pressure, volume, temperature, or amount of gas? ATM is one of the 5 different units that you can use for pressure, so that's going to be a pressure. Alright, 288 Kelvin. Is that a pressure, volume, temperature, or amount of gas? That is definitely going to be another temperature, because remember, Kelvin and Celsius are the 2 temperatures we have. What gas law should we use? Alright, we have pressure and temperature. So if we look at our gas laws flow chart, pressure and temperature is this one right here. So pressure and temperature, Gay-Lussac's law, is going to be the middle one. P1 over T1 equals P2 over T2. This is going to be Gay-Lussac's law. And here's the formula. Okay, so it says the temperature is already in Kelvin, so you don't need to add 273. So let's fill in this. Alright, so the first pressure, P1, T1, P2, T2. Alright, so the first pressure is going to be this 1.50 ATM, or atmospheres. How did I know that? You told me up here that 1.50 atmospheres was a pressure, and then there isn't another pressure in this, you know, whole equation here. Let's see, the first temperature that I encounter is 260 Kelvin. And again, how do you know that these two go together? If you read the top up here, they're in the same sentence together, so they go together. Alright, P2 is going to be our X, because it says what is the pressure up here at the top. It says what is the pressure. And then your T2 is going to be the second temperature, and it's 288 Kelvin. Alright, so let's plug these into this formula that's right here. So I'm going to do 1.50 over the temperature, which is 260, set it equal to X over 288 Kelvin. Alright, and the easiest way to solve this is just do cross multiplication. So you're going to go here, and you're going to go here. Alright, so I'm going to do 1.50 times 288 equals 260 times X. Alright, so remember the little dots mean multiplication. Alright, so 1.50 times 288, let's do that on my calculator, 1.50 times 288 gives me 432. Alright, and now over here, we've got 260 just times X, because we can't really combine those. Alright, since this is multiplication, to get rid of this, or to get this X by itself, we're going to divide by 260 on both sides. Alright, so that's gone. So now on my calculator, I'm going to do 4032 divided by 260. That's going to give me 1.66 equal to X. Alright, so now we have to ask ourselves, okay, what unit should it be in? It was the P2, it was the pressure. This one was in ATM, so this has to be in ATM as well, or atmospheres. So I'm just going to fill that in up here. ATM, atmospheres. Alrighty, we're so close to being done, there's only one left. Alright, number 4, it says, a 180 milliliter volume of gas has a temperature of 87 degrees Celsius. What is the volume of the gas at 0 degrees Celsius? Alright, so 180 milliliters. Is that a pressure, volume, temperature, or amount of gas? Definitely going to be a volume. Alright, 87 degrees Celsius. So degrees Celsius, that is going to be a temperature. So I'm going to write temperature here. Alright, 0 degrees Celsius. So 87 degrees Celsius was here, and that was a temperature. This is the same thing, so it's going to have to be another temperature as well. Alright, which gas law should you use? Alright, so we've got volume and temperature. So let's pull out this flow chart again. Alright, so we've got volume and temperature. We've got Charles' law. Alright, and then Charles' law here is the formula for Charles' law. Alright, so we're going to put that into here. What gas law should you use? It's going to be Charles' law. What formula should we use? It's going to be V1 over T1 equals V2 over T2. Alright, so let's put these into the chart down here. So V1, T1, V2, T2. Alright, so let's see, 180 milliliters. That was the first volume that we encountered. So it's going to go here for the V1, the first volume. Alright, T1 is the first temperature we encountered, or we, came up with. 87 degrees Celsius. But don't forget, we have to add this magic number, the 273, to get the Kelvin temperature. So I'm going to add 273 to this. 87 plus 273 equals 360. And for some of you parents out there who are watching this video, Kelvin is this scientific temperature system that scientists created in order to not have any negative numbers. So if you were doing a calculation like this and you had a negative temperature, it would mean that you would get a negative volume, and that's impossible. So they came up with this Kelvin system where 0 is this temperature called absolute zero, which is impossible to get to on Earth. So just in case you're curious or you're wondering, like, what is this Kelvin? That's pretty much what it is, and we've gone over this in class before. Alright, so now let's talk about the V2. It says, what is the volume of the gas at 0 degrees Celsius? So we don't know that. So that's X. Alright, and then the T2 is going to be 0 degrees Celsius. Don't forget, we got to add 273, and that's going to be 273. Alright, so let's plug this into this up here. So we've got 180 over 360, that's going to work out, that's just going to be 1/2, is equal to X over 273. Alright, and the easiest way that we can solve this is just to cross multiply here, so cross and cross. So on this side it's going to be 180 times 273 equals 360 times X. So remember, the little dots, they just mean multiplication. Alright, so on my calculator, I'm going to multiply these two together. So I'm going to do 180 times 273. That's going to give me 49,140, or 49,140. And then on this side, we only have 360 times X. So it's just going to be 360X. Alright, so now since this is multiplication, we're going to have to divide to get this X by itself to see what it's equal to. So I'm going to divide by 360 on this side. But then we also have to do the exact same thing on the other side. So I'm going to do 49,140 divided by 360. And that's going to give me 136.5. Whoops, almost goofed. 136.5 there. Alright, so this is 136.5 equals X. Alright, so now we have to figure out what unit we should put it in. So remember, the volume units have to match. So if this is milliliters, this also has to be milliliters. So I'm going to put milliliters there. And you can fill it into the box up here. 136.5 milliliters. Alright, and that's pretty much it for today. So remember, you can work ahead if you'd like. If you have questions, please email me, call me, comment on Google Classroom. Tomorrow is technically it was a teacher work day, so you don't have any assignments that are due tomorrow or Monday. But keep in mind that you do have assignments that are due on Tuesday. If you have any questions, please let me know. Have a great day.